Rolling. All right, here we go. Here's what we're going to do. We're going to do section 7.3 today. We've got to do our warm-up. Oh, Charlie. Forgot about Charlie. Started the video, forgot about Charlie. Charlie making a cameo on the video. Charlie, want to say anything to the folks at home? No. Charlie, man, if you would.
Charlie, good luck.
Charlie's going to take his sequences quiz. Wish him luck.
Good luck, Charlie.
These last things had some hard ones.
He does kind of look like Charlie.
Yeah, a little bit.
He's not even
All right, here we go, folks. So, and we're back. So again, we're doing section 7.3 today. We're doing this warm-up, going over I've got two homework problems here that I want to go through because every other one of them had like in the 80% correct rate, which is really good. Those two, as I checked this morning, it was like 70% and 64%. So I want to go through those two problems. And then we've got a notes set to go through. And that'll be it. So let's get to it. First things first, binomial times a trinomial. Now don't forget, for those of you, and there were some people first period too, that were trying to just give me an answer with no work. I mean, I consider myself to be very good at math. I can't do this problem without showing any work. So if you can do this problem without showing any work, here's the pen. There you go. Okay. You teach the class. 2x times x squared. 2x to the third. 2x times 3x. 6x squared. 2x times -4, -8x. Second set of distribution. -7 times x squared. -7x squared. -7 times 3x. -21x. -7 times -4. +28. You know, I let it go that you eat in my class, but do we have to have the loudest and crunchiest snack?
We're munching. It's good.
Oh my. Okay. Here we go. Let's keep going. 2x cubed. We got a 6x squared minus 7x squared is a -x squared. -8x and a -21x make -29x. And then plus 28. And there's my answer. So if you did something wrong, check and see where you made a mistake. Was it a negative? Did you drop a negative? Did you forget to multiply a power? Did you forget to raise it to the third? Whatever it may be. Check your work, folks. Check your work. All right. Any questions on the warm-up problem? No? I want to go over these two problems. I want to go over number 6 and number 11. So if you have your work for the online assignment, make sure you take a look at those two problems. Number 6 and number 11. Here's number 6. Now, I have to FOIL this. Now, I think where the issue's coming is this is misordered from the beginning. This is out of order from the beginning. What do I mean by that? That 4x should be before the 8. Now, that shouldn't throw us off too much, though. We can still FOIL. 8 times 2x is 16x. 8 times 6, this is the outer, is just 48. Inner. Now, be careful here. Usually our inners are not squared. This one turns out to be squared. -4x times 2x is -8x squared. Last, -4x times 6 is -24x. So my final answer should be, let me just do that, is -8x squared. Okay, bring down that term. And then we got a 16x minus 24x is a -8x. And then we bring over our 48. And that should be my answer. Questions about that? Again, that was, as it was this morning, that was at 70%, which I still think is pretty good.
Cost over.
And we work until the bell, right?
I mean, that's what you said.
I don't dismiss you, or you don't. What is it? Hell doesn't dismiss you. I dismiss
You know what's
you.
funny about that? The bell doesn't tell me when to get here.
That's true. Yeah.
See?
I tell you when to get it. All
I
right.
didn't
So
make it up.
this one has 64% correct rate. So let's go through this one. T times t squared. I think what was wrong here is that it was the last problem. You guys got like a little bit lazy. Just like whatever. Or it was just minus signs, and that threw it up. T times t squared. T to the third. T times negative 5t minus 5t squared. T times 1, just t. Or maybe your t's turned into plus signs or whatever. Negative 2 times t squared is a negative 2t squared. Negative 2 times negative 5t is a positive 10t. Negative 2 times 1 is a negative 2. And now we put our answer. Okay, we got our t to the third. And we got a negative 5t squared and a negative 2t squared to make negative 7. T and 10t make 11t. And then minus 2. And that should be our answer there. Again, if you keep it organized and stay in order and keep it nice and clear, it shouldn't be that big of an issue. 20 minutes to do this lesson. Say that?
Doesn't 11 sound like it could be really?
I know. I hate using T because it sounds like 11T, like 7T, 8T, 9T, 10T. No, why is anybody ever using the variable T?
Because it looks
If
like
it's not time,
Yeah.
All right, so now for section 7.3, I will tell you right now that you could probably do every single one of these problems on this guided notes and in the homework without listening to me at all today. You really could. Okay? Now, here's what we are going to do today, though. What I'm going to do today is teach you tricks. Teach you shortcuts. Because I know you guys like to take the path of least resistance. You guys like to take the easiest route. So that's what I'm going to try to teach you guys here. Now, the first thing that we have is what's called a square of a binomial. A square, now think about that. You know what that is. You square a binomial. So we're taking something to the second power, and we're squaring a binomial. Well, what's a binomial? Just two terms, right? So we're squaring a binomial. I'm going to take this first example here, x plus 5. Question.
I will listen to you. However, I do have a question. If we just want to do how we were taught originally, can we just do how we were taught?
Sure.
Okay.
That's a great point to bring up. Sid said, are we allowed to do this how I taught you over the last 2 days? Of course. Sid, respond back. Take it, put it in the pocket.
No.
Are you allowed to do this using the FOIL method? Yeah, of course. Now, here's the common misconception, though. We've actually done one of these problems before. You know what a lot of people might try to tell me the correct answer would be? X squared plus 25. And you would actually be pretty close, but you wouldn't be exactly correct. Remember that when we square a binomial, it has to look like this, right? X plus 5 times x plus 5, which means I need to FOIL it. X squared, 5x, 5x, 25. Now, what's unique about that? What's unique about this?
That you have two of the same variables.
Exactly. Look at my outers and inners. I have 2 of the outers and inners, right? Those are the exact same thing. X squared plus 10x plus 25. I'm telling you right now, every single binomial squared that you have, every single binomial squared that you have will come out this way. Where I square the first term, I square the last term. It was first term and last term are what we originally thought was going to happen. The squaring are just like distributing in the power. But the middle term is actually 2 times our inners and outers. 2 times our 5x here. Now, how do we get 5x? You multiply those two numbers together. So here's the trick. If you'd like it, here's the trick. You square the first. You take 2 times the product of the terms. And then you square the last. Square the first, double the product, square the last. A binomial squared will always come out in this manner. Now, I'm going to tell you right now that I don't use this one a lot. I don't use this trick a lot. I actually go back to foiling a lot. But I think it's valuable for time's sake to show you. Here's what I mean by it. I got 3x plus 4. I got 3x plus 4. Can we foil this? Of course. But let me show you. Square the first. What do I get when I square 3x? 9x. 9x squared. Let's jump to our last term. What do I get when I square 4? Square 16. Now, what's the product of my 2 terms? I have 3x and 4. What's the product of those 2 terms? What's 3x times 4? 12. 12x. Okay, I've got 12x. Double it, what do you get? 24x. That's my answer. Square the first, double the product, square the last. No work needed. Square the first, double the product, square the last. Let me show you that foiling, 3x plus 4. Foiling also works. 3x times 3x. 3x times 4. Another 3x times 4. 4 times 4. Don't I get the exact same thing? Okay, so foiling works the exact same way. But if you remember the trick, you can use the trick. What is the trick again? Square the first, double the product, square the last. Let me show you one more of those. Oops. Here we go. 5x minus 2y squared. All right, do you see how it's that same binomial squared? 2 terms squared. All right, square the first. What do I get when I square 5x?
25x squared.
Good, 25x squared. Let's jump to the last. What do I get when I square 2y?
4y.
4y.
Negative.
Oh, be careful, squaring it turns it positive. 4y squared. Now, the weird part about this is the middle term. Okay, what's the product of 5x and a negative 2y?
Negative
3x1.
Product. Negative 10xy. Negative 10xy. So the product of 5x and 2y is 10xy. It's negative. And then you double it, and what do you get? Negative 20xy. So my answer is that. Okay. Does foiling still work? Of course. Let me show you. 5x times 5x. 25x squared. 5x times negative 2y. Negative 10xy. 2y times negative 2y times 5x. Negative 10xy. 2y times 2y. 4y squared. Negative times a negative is a positive. And then we combine like terms in the middle, and we get the exact same thing as we said at the top. That's called a binomial squared. Binomial squared. Okay? That's called a binomial squared. Now, this next trick I use every single time. I never foil these next things. Question?
I'll ask you.
Okay, I never foil these next ones. It's called a sum or difference of cubes. Actually, it's called It's called a difference of squares. Here's what it is. If I take 2 squares like the two binomials like this, x plus 3 x minus 3. And I FOILed those together. I would get x squared minus 3x plus 3x minus 9, right? What happens in my inners and outers? They cancel. That will happen every single time we have this setup. What's the setup? Well, we have two binomials, and they are the exact same with exception of the symbol in the middle. They are the exact same with the exception of the symbol in the middle. That's the only difference between these two things. I've got an x plus 3 and an x minus 3. That will always cancel out our inners and outers. So what's left over? X squared minus 9. How do we go from the plus 3 minus 3 to x squared minus 9? Well, you just square the first, x squared. You square the last, 3 squared is 9. And it is always a minus sign. That's why it's called a difference of squares. Let me show you what I mean. I've got t plus 5, t minus 5. Got t plus 5, t minus 5. Could you FOIL this? Of course. I never FOIL this. What's my first term squared? T squared. What's my last term squared? And you just put a minus sign. Done. That's again called a difference of squares. Now, it had to be in this setup. What was the setup again? The exact same binomial. The only difference is one's a plus, one's a minus. Now, let me show you that the FOILing works. T times t is t squared. T times negative 5 is negative 5t. Positive 5 times t is a positive 5t. 5 times 5 is a minus 25. And they do cancel to get us back to our answer. But if you know the difference of squares trick, you never have to FOIL those. And that's really convenient. Let's take a look at this next one. Let's just go straight to our answer, shall we? Does it have the setup? People, I am done with the phones. Okay, starting on Monday, everybody's phones go back up here. Okay, starting on Monday. I'm sick of it. I'm sick of it, sick of it, sick of it. Everybody's phones go back up here starting Monday. I'm going to write it on the board so I don't forget.
Who ruined it?
Second period. Phones up. Phones up.
Mr. Lemerick, who'd you see? It wasn't me this time.
I'm not going to rat. All right, 3x plus 5 times 3x minus 5. Now, I square the first. What is 3x squared?
9x in the second.
9x squared.
9x squared. I square 25. What do I get? Oh, I square 5, I get 25. And then I just put a minus sign in the middle. And that's it. That's the trick. Yeah.
Is it always going to be a minus sign?
Always. Always. It will never be a plus sign. Let's FOIL that just to make sure. 3x times 3x is 9x squared. 3x times negative 5 is a minus 15x. 5 times 3x is a positive 15x. 5 times 5 is a negative 25. And then it does cancel. Questions about that? Okay, let's flip it over onto the back. Now, unfortunately, there's no trick for the ones in the back. I wanted to give you ones that are called a binomial cubed. A binomial cubed. These can get a little tricky. You need to stay organized with this. A very, very common misconception is that you can just distribute the 3. Can you distribute the 3? No. Please don't do this. Please don't do that. There is a lot of work that goes into that, and if you just distribute the 3, you're cutting off all of that work. Don't do that. Right, so just like we did with the squared, this is essentially x plus 2, x plus 2, x plus 2. Now, when I go to multiply the second two terms, look here. What I'm going to do is I'm actually going to start over here. Because if I take this binomial times a binomial, it's going to end up as a trinomial. And I want that trinomial to come second. Now, this first binomial that I've got here, I'm just going to drop that down. I'm going to multiply those two binomials together. All right, first outer and last. X squared, 2x, 2x, 4. All in total, x squared plus 4x plus 4. Hopefully you're getting quick with foiling now. Hopefully it's really coming easy to you now. Should be. Okay, so now what we have is a binomial times a trinomial. Oh, we did this yesterday. A binomial times a trinomial. I guess I should pause right here. Did anybody notice that we could have done the trick for the binomial squared here? X plus 2, x plus 2. Square the first, double the product, square the last. We could have done it there if we really wanted to. But again, I don't really use that first trick very often. I'd rather just FOIL it. So, but it's up to you. It's there. Let's distribute the x in. X times x squared is x to the third. X times 4x is 4x squared. X times 4 is a 4x. 2 times x squared, 2x squared. 2 times 4x, 8x. 2 times 4, 8. It's just what we did yesterday.
Just more.
This piece is exactly the same as we did yesterday. We just FOILed once before. Not too bad. And then we just combine like terms. X to the third, 6x squared, 12x, and then an 8. See, the nice thing is, these types of problems really reward the people that stay organized with their work. Because is this intellectually difficult? No. This is not like groundbreaking, like really hard mental stuff. What this is you keep doing the same things over and over and over again. And this kind of rewards those people that are really organized, really systematic about their work. You know who struggle with this? The people that think they can fly through things. The people that think I got this. I don't have to do this. I got this. I can do it in my head. Yeah. You can't do this in your head. Just telling you right now. Okay? But if you're one of those people that just takes their time, plugs away, stay organized, maybe you're not the person that gets it real fast, but you're the person that still, just kind of plugs away, does what they need to do. This stuff is for you. Okay. We got time. Let's do this last problem.
What time do we have?
We got some time. That's right. So 2x plus 3, 2x plus 3, 2x plus 3. All right, let's multiply these pieces together. 2x times 2x.
4x squared.
2x times 3. 6x. 3 times 2x. 6x. 3 times 3, 9. So I'm going to carry through this piece here. And this turns into 4x squared. And then we have a 12x plus 9. And now I use binomial, trinomial, just like what you did on your homework last night. 2x times 4x squared, 8x to the third. We have 2x times 12x, which is a 24x squared. 2x times 9 is an 18x. 3 times 4x, 12x squared. 3 times 12x, 36x. 3 times 9, 27. So all in total, looks like a 36x squared. Got an 18 and a 36 make 54. And then a 27. I will tell you that's about as difficult as I can give you in terms of how many steps there are. Not in terms of mental capacity, but just how many.
Hey, Mr. Labrador, that's 66x.
Is it 66? Wait a second.
Yeah.
That's 54. 18 and 36 make 54.
Oh, I missed the square on the edge. Or on the 12x.
Gotcha.
My bad.
Ding, 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 there goes the bell. How do we make it right?
You too.